Hello, Professor Tim.
Good morning. How are you?
I'm good, Professor. How are you?
I am very well. Great to see you again, Habil.
Same here, Professor. Thank you very much for your time and accepting our invitation.
Well, I'm very happy to see you again and to share some of the work that we've been doing at the university.
Thank you so much, Professor. Thank you. So with your permission, if you allow, can I formally join the session,
Yes,
start the session?
yes, you can. Yeah.
Yeah, okay. Ladies and gentlemen, thank you very much for joining us on this invited talk by Professor Tim McCarthy on sustainable housing and buildings. Professor Tim McCarthy was appointed as the Director of Sustainable Building and Research Center in February 2021 at the University of Wollongong. He joined University of Wollongong in 2004, and previously he held the chair of Structural Steel and Design at the Faculty of Engineering and Information Sciences. Professor Tim is passionate about sustainable engineering and engineering education. He was the principal investigator on a major research project into the use of cold formed steel in mid-rise residential buildings at the Sustainable Building Research Center. He combines his interest in renewable energy such as wave energy with onshore sustainability research. In 2011, Professor Tim was co-leader with Team UW and gained entry into the Solar Decathlon China 2013 competition. Team UW were the first team from Australia to gain entry into a solar decathlon and took a unique approach to the competition by being the first to demonstrate how to retrofit an existing home. Professor Tim will further share the detail of this Desert Rose project, which is a remarkable project because this project was later exhibited in the Dubai 2018 Expo with a net zero energy house. So Professor Tim will further share. Again, thank you very much all for joining, and over to you, Professor Tim.
Thank you very much for that introduction, Habil, and welcome to everybody who's joining this. I would like to first of all acknowledge that I'm on Darwin country. Australia is a nation that's been occupied by people for over 60,000 years, and I've only been here 20 years. And Australia has been affected by colonization in similar ways that to Pakistan. So we recognize that the people have been here before the European migrants came. Can I share my screen, Habil?
Yes, Professor, sure you can.
I'm just going to bear with me while I.
There would be a share option with you.
Can you see that yet, or is?
Not yet.
Um, I think it is loading now.
Yes, Professor, it's loading now.
Okay. And is that in the correct
It's still
presentation mode?
coming. Okay. I will just confirm when it's available to us.
Mm-hmm. So it's transmitting from a long way away.
Yeah. Yeah, we can see it now, Professor.
And is it in the correct mode for you? Is it in
Yes, Professor,
present?
it is in the correct mode. Yeah, it is
Oh,
in the
okay.
presentation mode.
Oh, okay. Well, I'll take you through. So thank you very much, and thank you for suggesting the topic for today. As you said, sustainable housing is something that I'm quite passionate about, and we have been working with solar decathlon contests since 2013. I'll tell you a little bit about the building that is behind me, and that I work in. The Sustainable Buildings Research Centre is itself the most sustainable building in Australia. It is the first building in Australia to achieve International Living Building Challenge certification and has the highest sustainability ratings of all Australian buildings. it's net zero energy and net zero water. And below the Sustainable Buildings Research Center, you'll see two houses, and these are the solar decathlon houses that our students helped to design and create for China and for Dubai. The value proposition for the Sustainable Buildings Research Center is that we want our built environment and our research really to make the sustainable society more of a reality. And we want to make in our case, every Australian be able to live comfortably and sustainably and well through our pioneering research. And that comfortable and wellness is a very important theme, that we need buildings to be buildings where people will remain healthy. So we don't want people to get too cold or too hot, and we want the humidity to be controlled. This is our solar decathlon team, very vibrant bunch of students who are here photographed in Wollongong with one of the lighthouses behind them. And this was taken before we embarked on our trip to Dubai. They're a big team. I'll tell you a little bit about Solar Decathlon itself. This was set up by the US Department of Energy, and it had its first outing in 2002. So it's been going for quite some time. What it does is it challenges students to design and build and operate a net zero energy building. And the important part of this is that the students actually have to both design and build, and we have to then transport the house from our location in Australia to the competition site. So one house went to China and the other went to Dubai. The requirements of the contest are that the house must be a net zero energy home. So it must generate more electricity than it uses, and it has to provide a great example of sustainability. And obviously, the last bit is that we must highlight the benefits of off-site and modular construction, because this house was built in Australia and the Desert Rose house was then transported by ship in 8 shipping containers to Dubai, and it was rebuilt in Dubai for the contest in only 2 weeks by our students. The Solar Decathlon contest has been all over the world, and I've had the pleasure to compete against teams from Pakistan when we were in China, and there have been contests also in India, Africa, and Europe, and North America and South America. The only continent that hasn't had a Solar Decathlon contest of its own is Australia, and we're hoping to change that maybe by about 2027 or 2028. The first house that we entered into Solar Decathlon was the Illawarra Flame House. The Illawarra Flame is a tree that grows in our neighborhood in Australia. And what we liked about the tree analogy is that this tree spends a lot of the time without its leaves, without its flowers, and it looks quite ugly. And then when springtime comes, it becomes beautiful again. So the idea of the Illawarra Flame House was to take an old, ugly house and make it beautiful again. And the old house, I don't know, maybe Habil has seen some of these houses when he was in Wollongong. We turned it into this house, the Illawarra Flame, and that's a picture of it at our campus in Australia. And as Habil mentioned, we actually won that contest in China. And here's a picture of our construction leader, Scott Redwood, kissing the trophy, and that was back in 2013. And one of the benefits of doing contests like this is that it trains people not just in the theory, but also in the practice, and then in the practicality of actually building a house and transporting it. Scott, who's shown in the picture there, kissing the trophy, he actually runs his own business in Wollongong at the moment, building sustainable houses, and has a very successful consulting engineering business as well. He actually employs quite a few of our students and is sponsoring one of my PhD students. So it's great to see the engineers who came through the Solar Decathlon giving back 10 years later. Now I'll talk about the Desert Rose house. This was our house that we sent to the obviously the desert. It went to Dubai for the contest in 2018. The contest itself, it is a solar decathlon. That means that there are 10 contests that the students must compete in. For Dubai, we had sustainable transport. That means we had to charge an electric car from the solar panels on our roof. We had a contest in engineering and construction, house functioning, so they're keeping the temperature below 25 degrees and the humidity below 60 degrees at all times. Contest in innovation, sustainability, energy efficiency. Communications was one where we were allowed to bring in our media students because they had to create a website, videos, podcasts, and so forth. And finally, there was architecture and energy management. So we had to prove over a 2-week period in Dubai that our solar decathlon house would generate more electricity than it needed to run the house and also charge the car. But on top of that, there was a technical challenge to make a house that is net zero energy that can be built in 2 weeks and so forth. And our students decided to go one step further and to give themselves a challenge to make the architecture work for people. And the people that they wanted it to work for in particular are old people. As the population gets older, we have more people over 65 than ever before in Australia, and that's happening around the world. And with the extra life expectancy, we're getting people that are experiencing more age-related diseases. And in particular, the age-related disease that I'm going to talk about is dementia or Alzheimer's disease. We'll talk about the floor plan of the Desert Rose House and how that plan itself and its architecture assists people living with dementia. I'll just show a picture of our students in the early days before they knew how much hard work it was going to be in a design workshop. And in these design workshops, we talked to experts in healthcare, in aged care, and people living with dementia themselves. Now, I'll talk a little bit about this, the problem of dementia. Dementia is a brain disease that affects quite a lot of people, particularly those who are over the age of 75. In Australia, it is the leading cause of disability for people over the age of 65. We currently have over 400,000 people in Australia living with dementia. And what happens with dementia, it's an incurable disease. Your brain gradually ceases to function. You forget things, you don't recognize places and so forth. And it is currently the second leading cause of death in Australia. Now, as other countries have improved healthcare and nutrition, we're seeing the pattern that's happened in Australia in the last 50 years also occurring in the Middle East. It's occurring in India. And while currently the dementia rates in Pakistan are probably around 200,000 people living with dementia, that number is set to grow exponentially in the next 2 decades. So these people, they have a horrible disease. It is eventually going to kill them, but they can still live in the community for quite a long period, provided their houses support their needs. And we'll see how the Desert Rose House supports the needs of somebody living with dementia. In designing the house, we consulted with local dementia agencies. We're fortunate that on our campus, we have the Dementia Training Australia headquarters, and we talk to nurses, occupational therapists, and also people living with dementia about what makes their house easy to live in or difficult to live in. You probably can't read this, but one of the activities that we did was with people living with dementia, we went through everything they do every day of the week, from getting up in the morning to going to bed at night, and making sure that our house allows them to do those activities, even if they have poor vision, poor mobility, and they forget things. In designing a house, we think of it in spaces. So we have places for eating, cooking, sleeping, relaxing, entertaining, meeting people, and cleaning ourselves. So we can divide a house up into all of these activity spaces. But some of the important things that we then have to incorporate within the design, now this was our floor plan that our students came up with. They looked at having 2 bedrooms, a dining room, a bathroom, and this floor plan changed dramatically when we started to apply principles of dementia-friendly architecture. So this is the final design that we ended up with. And the blue arrows that you see, I'm hoping that I'm not talking too fast for the slides, but these blue arrows indicate lines of sight. And this is what supports somebody who forgets where they are. So if somebody is in bed in the top left-hand corner, they can, let me just see if I can, so if somebody's in bed around here, they can see into the bathroom and they will see the toilet bowl, they will see the shower, and when they wake up, they'll know that that's where they can go to the toilet. And research has shown that people who are living with the advanced stages of dementia are 8 times more likely to use the bathroom and keep themselves clean if they can see it and they can recognize it. If they can't see it, then it's quite likely they will not recognize where it is and they will search for it, and that can lead to problems. Either they get lost in their own house or they think another room is the bathroom. Um, the other thing that we see on this is the other lines of sight is that from the dining room table, you can see the bathroom, you can see the kitchen, and so you will use the facilities. People with dementia, they're still able to function, provided they can see what they need to do. So if they see the kitchen, they're more likely to go and make themselves some food. So line of sight was a really important aspect of this. Now, a second aspect of the floor plan that was counter to this is the need for privacy. And we were building this house for a Middle Eastern client. So in Dubai, most people are Islamic, and we need areas of family privacy, and we need to be able to separate the guest areas from the the private areas. And so we've achieved that within the house, that when you enter the house through the front door, the family can go through this door and the guests can go through this door. And the guests have their own private bathroom and they have access to the outside area at the back of the house as well. So the family and the guests can be separated. And now that's, you might think that's normal, but in Australia that's not normal. In Australia, houses are open plan and there are no private areas in many houses, and that's a problem for our potential client. Now, moving on to what does the house look like from the outside. So the dark part of the roof are the solar panels, and the solar panels on this house also deliver hot water, and they're integrated with the roof tiles. So it's an integrated photovoltaic thermal system, and it's also integrated with the building. So we don't have separate solar panels. Around the side of the house, you'll see there's a light colored wall, and I'll talk a little bit about that later. That's a shading wall that was made out of lightweight concrete that was designed and manufactured by some of our students. Inside the house, we see this is the floor plan looking from that guest area back into the dining room area. And what you see here is a glass wall that's got opaque glass that can be closed to make the guest area private from the dining space. So that sort of meets 2 requirements. It meets a requirement in Australia to have open plan houses, but also meets the requirement to be able to have a private space. We can close the wall and that then becomes a private space. From the bed, I mentioned looking at the floor plan. Well, if you're in the bed and you wake up in the night, you can see the bathroom. And that makes it more likely that you're going to use it if you're living with dementia. Another aspect of this is that there's a color contrast between the wall and the toilet, so that we can actually recognize the light toilet bowl against a dark background. That's very important when people have low vision or vision, which is one of the symptoms of living with dementia. But those things can be in the architecture, they're very difficult to fix later once you have a house that's already built. Here's some pictures of people touring the house. So it is a fully functional house. And one of the tools that we used during the design was we used augmented reality. And before we had built the house, we could actually walk around the house using a Microsoft HoloLens. And here's one of my students using a walking frame to simulate walking around the plan of the house. And he can actually see the walls of the house. He can see the furniture and so forth, and kind of estimate how difficult it is to navigate the floor plan. And that's a very powerful tool in design, that we can actually use virtual reality and augmented reality to see if the design is going to work for somebody living with dementia. Here's a picture of our house in Dubai. So in November 2018, we unpacked the house from its containers, and in 2 weeks, we built it, a fully functioning house, and we entered in the contest against all the other teams from around the world. I'm going to talk a little bit now about the design, because I know there are some structural engineers in the audience. Excuse me. It's unusual for a house to have a floor load of 5 kilopascals. And the reason it's such a high floor load is that this was designated as a museum in Dubai because it had so many people coming to visit it. So it was designed way above residential loads. It was also designed for quite high wind loads, even though in Dubai it was only in location for a month in total. So those are the loads. So if you have a look under the house, if you ever come to Wollongong, you'll find that it's probably got twice as many piers and foundations as you would have on a standard house. The house was built using cold formed structural steel and some hot rolled structural steel, but mostly it was cold formed light gauge structural steel. Because we were transporting the house across the world to Dubai and we brought it back from Dubai, we wanted to be able to do that without too much weight. We also wanted to be able to build a house quickly and take it down again, because to move it back to Australia, we had only 1 week to dismantle the house. The wall frames came, they were designed by our students, but they came from a company called Enduroframe. And all the pieces came with a barcode on them and a piece number. And the students who didn't have any building experience were able to assemble these walls a bit like a construction kit with all the parts labeled and the drawings telling you where to put them. Here's a schematic of the structural frame of the system. So all of those wall panels came apart from the house and were transported in containers. They were fully made up with all of the layers of the wall in place and the wiring and plumbing ready to connect once it got to the building site in Dubai. Here's some pictures of the house being built in Dubai, and you see one of the wall panels. It already has all its finishes. It's got its window in place, and that then just gets lifted into place and it gets slotted onto the rest of the house. The roof was comprised of mainly modular scheme, and we built in the air conditioning system into the roof on the ground and then lifted that up in one piece. And here we see the roof module over the bathroom that already contains all our heating and cooling systems in place. And that was a night shot from construction in Dubai. Here's a picture of our happy students and one of our technical staff. And here's what they look like after a hard day's work in the heat of Dubai. The building site itself was in the desert near the MBR Solar Park, which is about 50 kilometers outside the city. So we had a 50-kilometer bus ride each day. And most of the time on the way back, people spent their bus ride asleep. I'm going to finish up now with a picture of the house at night in Dubai. And I think we're going to have some time maybe for questions if you want to ask any questions. And here are my contact details. We also have a website which has a lot more detail about the Desert Rose House than I've been able to go through today. So I'll pass back to Habil and see if we have any questions from the class or from anybody else online.
Thank you very much, Professor Tim. We really appreciate it. So if there is any question, just raise your hand. To the external attendees, please raise your hand. We will turn on your mic. And if there is a question from the students in our classes, please feel free to ask your instructor and they will facilitate your questions through the mic. Yeah, Dr. Temu, please go ahead with your question.
Hello, thank you, Professor, for this presentation. I just had one question, and that has to do with the designing, the interior designing of the architecture. That's essentially, as civil engineers, we really don't learn much about the design principles or how people living inside would actually, like things like line of vision and things like that. So, when you're building this house, how exactly did you emphasize this aspect? Like, how did you come to learn about it or enforce this aspect on students that, hey, look, how this is how we approach things, design sense instead of just as a structural engineer or materials person.
Yeah, thank you, Dr. Taimur. That's a great question. And it was one of the hardest things at the start of the project. Engineers are very good at solving problems, but sometimes we solve problems that others don't want us to solve. And so we set up a consultation process that our engineers were not allowed to design anything without talking to a nurse or without talking to an occupational therapist. And so we're lucky that we have those people on our site. The the team that we had put together was broken down into 5 sub-teams. And one of those sub-teams that actually ruled all the others was our well-being team. So the architects, the engineers were not allowed to make any decisions without consulting the well-being team. And that changed some of the designs quite radically and some of the technology that we put into the house because our control engineers wanted to make the house fully automatic. All the blinds will open when the sun comes up and the doors will open as you walk towards them. And the occupational therapist said, we don't want to do that because when somebody is old, we need to make them active. So we need to make them do things, give them activities. So if you automate everything, they'll just stay in their seat and they'll listen to the radio or watch the TV. So we need to get people out of their seats to open doors, open windows, open curtains and blinds. And that was a challenge for our engineers who said, oh, I can automate all of that and I can make it happen almost predictively. As we talked about the line of sight, that was a complete change of design once the dementia-friendly architects came in and spoke to our students. So we had a workshop on a Saturday morning where all our students came and went through the design principles for aged care friendly design. And that really helped to get everybody on the same page. One of the beauties of the project is that it's not just an engineering solution. It's an engineering solution for humans to live in this house and to uh, be healthy.
Thank
Yeah.
That is wonderful. I mean, like the real sense of the design is being met. Like if you can't design a structure, a building like this without consulting the real stakeholders or the designers, like as Professor Tim mentioned, and that is wonderful. So we have another question from Muhammad Shazib. Muhammad Shazib, Dr. Taimur, can you please turn on Muhammad Shazib mic and his video as well, if he is willing to share his video. Muhammad Shazib, please go ahead with your question. You are unmuted.
Hi, doctor. I'm Shazib from Pakistan. I'm one of the students of Dr. Habil, and I'm a civil engineer. But I started a construction company back in 2019. And the main purpose of the company was because the name of the company is Green Builders, and we are actually three partners, and we started this company. So the purpose was to start a sustainable construction here in Peshawar, mainly in Pakistan. So we have done with 12 projects, but the main problem that I'm facing right here in Pakistan is the cost and the total people are they want to do want to make the sustainable buildings, but when it comes to cost, they think that this is not that much sustainable, and the overall thing is went into the initial cost. So I would like to ask that the total cost that the desert house that you have built, what it went from start to end, what was the total cost that this house needed?
Okay, look, that's a great question, and there is a perception particularly in the public's eye, that sustainable buildings are more expensive than your traditional or cheapest possible building. Well, they're certainly more expensive than the cheapest possible. Um, the if and we have to look at not just the cost of the build itself, which many people focus on, but on the lifetime cost of the building. And that's where some of the sustainable investments have their payback. You asked about the cost of this building. It's very difficult for me to tell you how much it cost because most of the building materials we got for free. They were sponsored by manufacturers. We have things in the house that I would not put in my own house. For example, the windows in the Desert Rose house are all triple glazed. And if I was to buy them for my own house, it would cost me, I don't know, $65,000, which is an enormous amount of money, even in Australia. So if I was building this house in Australia for myself, I would use double glazed windows, and that would cut the cost of the windows by 50%. Some of the other features as well were donated by suppliers, and sometimes we co-design them with suppliers. What we do estimate is that this particular house, and you must remember as well that this is I call it a Formula One house. It's a house for the future. It's not a house that we can build readily today. And we expect that maybe in 10 years' time, this will become a common type of house to be built. We found that with our previous house, which was built in 2013, that pretty much everything in that house was brand new at the time and had never been done before, is now commonplace in Australia. So what we have done is we've estimated the cost premium per square meter, and we reckon that the cost of the Desert Rose house, because it has so many novel features, is about 2 times the cost of a standard house. But if we took out some of the features that are probably not needed at this stage, it's maybe 1.2 times the cost of a normal house. So there's maybe a 20% cost premium. Having said that, this house will never have an electricity bill. It will never have a gas bill. Its hot water will always be there. And so if you add the, the the premium of not having any energy bills going forward, and that the temperature in the house, even though it is built for the Dubai climate, will always be between 25 degrees and 23 degrees. That will make the house a very healthy place to live in and a very comfortable place. So yes, there's a cost premium when you want to build something that is new, and we have to probably separate the novelty cost or the innovation cost versus the um, the, the normal cost, because as products become more available, then their unit cost will come down. An example of that is the cost of triple glazing. That triple glazing in Australia is very expensive because it's very rare. In Europe, particularly in Northern Europe, triple glazing is actually cheaper than double glazing because it's more common. And the manufacturing is set up to make it in larger quantities. So they've got the scale factor to make it cheaper to have a better window in Northern Europe.
Got it. Thank you.
Okay, so another question is from Shah Saud. Shah Saud, your mic is unmute if I'm not wrong, so please go ahead with your question. Shah Saud, you are unmuted now. Please go ahead with your question. All right, I think Shah Saud might have some network issues. So is there any other question?
We can say that if you're having any network connectivity issues, you can also insert your question into the chat. I'll be keeping an eye on the chat in case you have any questions there.
If you have difficulty in unmuting your mic or something like that, you can ask a question in the chat as well. Our team is observing the chat, so your question won't be missed. All right, Shah Saud is still struggling, but if there is anyone else want to ask a question, please feel free to raise your hand. Yes, Arsalan Raza has a question. Yeah, Arsalan Raza, please go ahead with your question.
Yeah, thank you. I have posted one of the students' question in the Q&A section. If Professor Timothy can answer that. And I have another question that based on your experience, how can we convince stakeholders to prepare their vision for sustainable housing?
Okay, well, I'll answer the question. I can't see the question in the chat, so maybe Habil, if you can find that and read it out.
Yeah, Professor, the question is, how can sustainable construction practices be integrated into retrofitting existing buildings?
Yeah, look, that's a really good question, and it highlights
I will
the fact
copy
that
paste the question in the chat box.
yeah,
It was in the Q&A session. Yeah, so the question is,
you got my question?
How can sustainable construction practices?
So we'll talk about that. Talk about retrofitting. Most of the houses that we have already been built. So it's very important that the houses that are there we can improve. And so retrofitting is a
Sir, you online webinar के मज़े से कॉल पे क्यों था?
got somebody. How do we convince people about retrofitting? That's in different countries, they're doing this in different ways. In Australia, they've just announced a government scheme where if people want to do an energy efficiency upgrade to their house, they can apply for a government loan for up to about $10,000 in order to either replace old water heaters or put solar panels. And typically, to put solar panels on a house in Australia, it costs about $5,000 to do that, to get enough electricity for a house. To replace the hot water system is probably another $3,000. And to insulate the house to make it more thermally efficient is probably another $2,000. So for $10,000, you can fix most houses in Australia. The cheapest retrofit that we can have for most houses is to improve their insulation properties. So you get a lot of heat coming into houses through the roof. So if we have roof insulation, we can protect the house from that solar radiation. Some of the other technologies are quite expensive, particularly in countries that have developing economies. So I think the first thing is to make sure that your house is well insulated, well sealed, that the windows and doors close nicely and so forth. Then the next bit is the technology. If you have air conditioning, that's going to be expensive to run. So what I think is if you need air conditioning, you also need solar panels. And it's quite good that the need for air conditioning a lot of the time matches the availability of solar electricity. That when the sun is out and things are hottest, that's when you need the cooling most. Other things that can be done in houses is to create thermal mass so that we can actually store the cool of the day that we can generate from solar power into air conditioning. We can store that in heavy structures like brickwork, stone floors, and so forth. So hopefully that's addressed it. But the retrofit needs are going to really depend on the vernacular architecture where you're actually building, and trying to find the low-hanging fruit. And mostly the low-hanging fruit is draft proofing and insulation. Applying technology is expensive, but will have a payback depending on your energy costs.
Well, thank you for answering that one, Professor. Shasood question is in the chat box that Shasood says that I'm a contract engineer and I only want to ask about your contract type and how is responsible for communication between the stakeholders of your project.
Okay, well, the Desert Rose house itself was a competition, and the house was designed and built by our students. So the contracts that we had were mainly with suppliers. We also had a contract with the organizers of the contest because they agreed to give us prize money if we won the contest. But that contract was not a commercial building contract. When we brought the house back to Australia and reconstructed it on our campus, we did hire a contractor to put it back together again, and that was a standard measured contract. So we actually measured the work that was done and paid the bill every week. And the reason we did it that way was because the builder had never done anything like this before and was afraid to give a fixed price because it was reconstructing a house that had already been built 3 times and had been taken apart 3 times. And so we did a measured works contract for that piece of that final reconstruction. But that wasn't a function of, that was a function of the fact that this was an unusual build.
Thank you very much, Tim. So we can only take one more question, and that is from Sharoon. Sharoon, if you are unmuted, please go ahead with your question.
Hello, can you hear me,
Hello.
Dr. Habib?
We can hear you.
Okay.
We can hear you. Please
Professor,
go ahead with your question.
Professor, thank you so much for the valuable talk. It was most of this type of construction methodologies are novel. Even um, if we take the materials or the construction methodologies, so to me it looks a bit novel to the construction industry. So my question is, do your research center have worked on the building codes and regulations? And do you have any strategic alliance with the regulatory bodies and the government entities for its application and motivation in the construction industry?
Okay, thank you for that. And you're right. There's a lot of things in the house that are novel, and that's partly because it's a competition, and our researchers want to showcase the latest things. What we have found is that it takes about 5 years from building a house like the Desert Rose for most of the things in the house to become commonplace. So we're maybe 5 years ahead of the pack. And then it takes about another 5 years for those things to be embedded within the construction codes. Our center does do work, and we've got a number of projects at the moment with the Australian Buildings Codes Board. And much of that work is about how far can we push design and still keep it competitive and make the buildings more energy efficient. Our government has set a target of having all buildings net zero energy by 2050. And we're working with the codes on how they need to improve the energy efficiency standards every decade in order to achieve that target by 2050. We can't do it all in one go. So we're working on what are the changes to the building standards that are needed now. And we've got a new version of the Australian Building Code coming out in July this year, which mandates much higher energy efficiency than the previous code. And that's based on the simulations and the results from work that we've done at the Sustainable Buildings Research Centre. So we're ramping up the energy efficiency from 6 out of 10 to 7 out of 10. And that's actually a step change for building quality in Australia. And it means that the 10 out of 10 is a passive house, a house that does not need active heating and cooling. So 7 out of 10 is very close to being a passive house. And that's based on the work that we've done and the work that we've been doing with the National Construction Code.
Thank you so much.
Thank you. We can only just take one last question from the student. Arsalan, can you please facilitate that question?
Yes, thank you. So, Professor, based on your experience, how can we convince stakeholders to pursue this vision of sustainable housing?
Okay. Yeah, so that was convincing stakeholders. I think seeing is believing. If we can create examples for stakeholders to visit, even to stay in and live in, they will begin to understand the benefits. And that's what we find when we have visitors to our house, that the weather may be very hot and humid outside, but as soon as you come into the house, even though the HVAC has not been turned on, it is nice and comfortable inside. Other aspects that really build the thing, demonstrate its features, have case studies where we can show that extra investment up front gives you a payback both in lower energy bills, but also a more comfortable house, maybe a quieter house. So if you live in a noisy neighborhood, double glazing is a great way to reduce the noise in the house. And I think if we can build demonstration projects, and they don't all have to be a solar decathlon, which is trying to win a world contest. And our Desert Rose house came second in Dubai and got a prize of 800,000 dirham, which is about 350,000 Australian dollars for that. And that's a bonus for us. It helps to pay for the extra costs. But I think to get stakeholders interested, you need to give them examples. People will be skeptical until they actually see the product.
Thank you very much, Professor Tim. With this, I again thank you very much, Professor Tim. We are really grateful for this wonderful talk. Thank you to all the participants as well. And above all, I'm really grateful to the organizers of this event, Dr. Timur, Arsalan, Shoaib. There are many names to all the team members. And we're looking forward to such sessions by Professor Tim in future as well. They are really helpful for us to get know about the sustainable housing, because as I earlier mentioned, Professor Tim is very passionate about the sustainability, and sometimes it runs as his blood, and he's very passionate at that level. Professor Tim, again, thank you very much. We are really grateful, and thank you very much to all the participants.
Thank you very much for having me, and good luck to everyone.
Thank you. Thank you. With this, I end the session. Thank you.